Hi everyone. Thank you so much for joining us this afternoon for this webinar. Just let me give you a quick introduction before we get started. Last year we released our first white paper entitled "Should You Be Using AI in Your Business?" And one of the key contributors, CTO and co-founder of Deep Instinct, Eli David, is here with us today, and he's going to talk us through some questions that you might have about the paper, and we're going to discuss the topic a bit further. Before we get started, if you've not had a chance to read the paper yet, it's actually attached today, so please feel free to download the PDF and have a look after the webinar. If you have any questions throughout the webinar for Eli, please pop them in the chat box at the bottom of the screen, and we'll go through some of them at the end of the discussion. We'll also be sending an email round after the webinar with a recording as well as all of the slides. So hi Eli, thank you so much for joining us today. It's great to have you here.
Hello, great to be here.
Perfect. So before we get started properly, it would be great if you could give us a bit of a background about how you began your work in AI, and also a bit of information about your current work at Deep Instinct.
Sure. My background has mostly been academic for the past 10 years. After I finished my PhD 10 years ago in the field of neural networks and evolutionary computation, I've been in the academia supervising master's, PhD students, published over 40 papers in the field of neural networks and evolutionary computation. And since 3 years ago, I co-founded Deep Instinct, which is a company around using end-to-end deep neural networks, deep learning, for detecting and preventing new malicious attacks.
Okay, brilliant. And so what do you think are some of the biggest misconceptions about AI?
It's funny, Dan Ariely, the leading behavioral economist, recently said on big data, but I can use it for deep learning as well, that everyone is talking about it because everyone thinks everyone else is doing it. Nobody knows really how to do it, so everyone claims they are doing it. And that's a bit my feeling about AI. Nearly every company says we're AI first, we're doing AI. But saying AI in general, it's not something new. It has been out there for the past 30 years, at least nearly everyone's using it. So when people say AI today and get excited about AI today, they usually refer to a subfield of AI. Now, within AI, we have the subfield of machine learning, which encompasses many different families of methods that allow the machine to learn by itself from the data. And within the machine learning subfield, we have another subfield, which is deep neural networks, also known as deep learning. And nearly all the exciting advancements in AI in the past few years are due to this specific subfield of deep neural network. So when people say about the recent advances in AI, usually we should refer only to the advances in deep neural networks and deep learning, because they contribute nearly all of that.
Mm-hmm. Okay, brilliant. So how has AI gone from being used in huge tech companies and in research and academics to pushing forward to be applied to businesses and enterprises of all shapes and sizes?
If you look at the field of deep learning 10 years ago, well, back then we didn't used to call it deep learning, we just called it neural networks. It was probably the most the worst thing one could do in the academic world. Nobody wanted to do neural networks. It was considered nearly refuted field. And what happened in the past several years is that nearly overnight, it resulted in the most exciting breakthroughs, 20 to 30% improvement in nearly all benchmarks of computer vision, speech recognition, text understanding, etc. So there were a few academic research groups working on neural networks because it was so unpopular. And due to that, today there is an extreme scarcity of resources, mainly human resources, researchers who are experts in this field. So we see a very big competition amongst companies for bringing the best human experts. So the number one barrier of entry, I would say, is acquiring the human experts. And then trying to see what's the data they have, what kind of problems they would like to apply that to, and see whether they can use deep learning models out of the box using some open source frameworks, or in some cases these frameworks have too many limitations for the specific use and to start to adapt them. But again, the biggest problem and the biggest opportunity is by bringing the correct deep learning experts.
Okay. And with these organizations, almost as you said, rushing to implement AI because it's boomed so much over the years, how can people ensure that they have the right skills in place within their organizations before they rush into implementing it?
Even though deep learning is the most exciting field and the most exciting results are due to that, I would actually recommend against just going to deep learning because it is the best thing. If there is a problem for which traditional machine learning, for example, provides good results, then of course it is preferable to use that because deep learning is frankly a big headache. So my rule of thumbs for any organization and any solution for deciding whether they need to move to deep learning or not would be deep learning is useful only if the following three conditions apply together. First, the traditional methods that they use, whether heuristics or machine learning, they don't bring good results. If the result bring good enough results, then that's fine. Second, they must have huge amount of training data. Deep learning, even more than traditional machine learning and other traditional fields within AI, requires much more training data because we train neural networks on raw data and we expect them to do the feature learning by themselves also, which is highly dependent on the amount of data that they have. And third, the kind of data that they're having should be complex. If the data is not complex, imagine a nice database of structured data, orderly columns. When in that case, there is not a big problem doing feature extraction. Those columns in the database are the features, and so traditional machine learning using linear models should obtain pretty good results. So only if these three conditions apply, huge amount of data, complex types of data, and traditional methods do not obtain good results, then in this case, I truly believe that using deep learning, despite all the barrier of entry and the complexity, will yield a huge improvement. And that has been my experience in various areas within the real world, in the industry, and also in the company that I co-founded.
Okay, amazing. And you mentioned open source software just now. Do you think that's the best option?
If, let's say, 5 to 6 years ago, you wanted to implement deep neural networks, that was really, really difficult. As we know, implementing neural nets and training them on GPUs, mainly NVIDIA's GPUs, it's nearly close to 100 times, usually several tens of times faster than training them on CPUs. So it is not practical to train them on CPU. You do need to train them on GPUs. And a few years ago, you needed to write most of that on the GPUs yourself. It's like implementing complex algorithms directly on top of GPUs using low-level CUDA, the GPU programming language. Thankfully, in the past few years, we now have very good deep learning frameworks, for example, TensorFlow backed by Google or PyTorch, mainly backed by Facebook, Microsoft Cognitive Toolkit, which is also a great deep learning framework. And all these frameworks allow the researchers to directly focus on the research instead of having to deal with low-level programming. Now, there are problems and limitations with these frameworks as well. They are not always the best option. The main problem is that they're mainly developed by researchers for researchers. So while they're very good for research and also for academic research, for example, my students at the university use them. They're very happy with them. These frameworks are usually too inefficient for many real-world commercialization and a productization use. And in many cases, they're inefficient because of the dependencies that they have on external libraries, because of the inefficient memory use, the latency, and the fact that usually always you can run them in a cloud or server, and they cannot be used for endpoint deployment. For example, if you like to directly put it within the product on a mobile device or a laptop or desktop, etc. And additionally, these publicly available frameworks usually expose high-level building blocks like convolutional neural networks or recurrent neural networks. And as long as the use case is within these traditional areas, for example, computer vision is a great example. Nearly all the users use convolutional neural networks. That would be great. But if we take another example, like what we do in Deep Instinct in cybersecurity, a raw computer file, an executable file, it doesn't have local correlation, so we cannot use convolutional neural networks. The sizes of the files are different, so we have to adapt the algorithms to cope with that. And these kind of modified deep learning algorithms usually cannot be implemented on top of the publicly available frameworks. So in these cases, one may have no better option than to directly implement them on CUDA and NVIDIA, and that's quite complex. But again, for most research tasks, these open source frameworks are great.
And as it has become so much easier for companies to implement AI and deep learning, do you think I mean, there's so much discussion at the moment about AI coming in and stealing jobs. Do you think that that's true, or do you think it could actually be creating jobs?
I think there would be two waves. The first wave, in the next few years, indeed, advanced AI solutions will take more and more jobs. But the wave that will come after that is that humans and the machines working together. So the result of our cognitive capabilities together with the best AI would provide a result that is more than the sum of its components. And that is my belief, that if we look at 10 years from now, AI will not take our jobs, but our jobs will become much more interesting and much more sophisticated.
And how do you mean by that? Is that because we won't have to be doing the monotonous tasks that AI will come in and replace for us? Hello? Hi, Eli, can you hear me?
Yes, sorry for getting disconnected. I just
That's okay,
reconnected.
no problem.
So I may have missed your last 60 seconds.
That's okay, don't worry. No problem at all. Sorry about that, everyone. Yeah, so moving on. So there seems to be so many new progressions in AI kind of every week, really, at the moment. And what actually is it that's allowing research to move so quickly?
Two things happened several years ago that resulted in such a huge spike of interest in this field. The first is that if you look at the neural networks during the 1980s, 1990s, and early 2000s, we could train only shallow neural networks, just a few layers, a few thousand synapses. We couldn't really train deep neural networks. So the first is that we managed to bring a series of algorithmic improvements that allowed us to train deep neural networks, basically much bigger brains for solving problems. And the second is the adaptation of these algorithms to run on dedicated hardware, mainly GPUs, which again allows us to do the kind of training that would take several months within a few days. So that was the reason behind the current deep learning revolution, so to speak. And right now, if we look at the number of papers in this field, we see many tens of papers, nearly hundreds of papers every week being added. Now, if somebody is a new researcher in this field, at first that may be overwhelming. For example, my new students always tell me, well, what can I do when there are hundreds of papers every week? But most of these papers are small incremental improvements. And usually once every few months, we do see also substantial improvements in new paradigms. But if we look at the bigger picture, we zoom out and we look at the bigger picture the past 2 years, we see a clear accelerating pace of results here. So whereas in the previous excitement about AI in the previous decade, it was usually a slow improvement, and after each big improvement, there was a deceleration of results. In this case, we see a very clear exponential growth in the kind of results we obtain, in the improvement in various benchmarks we obtain. So to extrapolate from this trend, I certainly expect that next few years we will see a continued exponential growth and the improvement of results in this field.
Okay, brilliant. So looking towards industry and applications, how do you think AI can provide a better customer experience for companies providing these kind of services?
It depends again on the domain. In problems involving computer vision, in most of the problems involving computer vision, we see that deep learning today is nearly as good as humans, whether that's face recognition, object recognition, event recognition, etc. And we see really great applications of that in real world, from autonomous driving to medical image analysis. So any company that has anything to do with vision would be very strongly advised to try to adapt deep learning, because the results will usually be a very huge improvement. Same in speech recognition. We've seen the greatest leap in performance in speech recognition in the past few years, and the improvements are great. The results of speech recognition, deep learning-based speech recognition, is still not on a par with that of humans, but it's getting very, very close. In text understanding and natural language processing, we've also seen a very big improvement in the past few years. Language understanding is a much more complex task. No wonder that only the mammals with the biggest brains, such as humans, do have complex languages. So evidently that is more complex for the machines as well. But again, we see big improvements in that field as well. So if we look at the trend in text, speech, vision, cybersecurity, games, financial applications, we do see that nearly every industry and in every problem domain, companies that switch to the application of deep learning, they do see big improvements. And the results of those improvements are direct improvements experienced by their customers, but more accurate predictions, more accurate problem solving, etc.
Yeah, of course. And for these companies who have employed deep learning, how can this also help with optimizing business efficiency?
Actually, that's a very interesting domain. Many of the business efficiency-oriented solutions in the traditional sense, they rely on human-specified heuristics, trying to understand what are the processes where improvements could be made. Now, those companies who have tried to use deep learning have experienced big improvements in this field, assuming they do collect and store large amounts of data for all of their processes. But when you analyze these large data sets of data and log files of everything that happens in the organization, and you allow such a deep learning module, or even a traditional machine learning module, to train over that, you uncover many patterns and correlations that could directly be translated to more efficiency, that without these automated learning methods, no human could manually be able to discover them. A very good example of that is the recent work published that the DeepMind group have done within Google, optimizing the electricity efficiency of the server farm that is something, and the kind of patterns that they discovered is something that nobody can manually try to think and execute.
Yeah, that's really interesting. And also, kind of building on this, how will AI allow companies to obtain or sustain a competitive advantage?
In some fields, for example, in computer vision, the barrier of entry is a bit lower. So any company that's today doing computer vision and is not doing deep learning will be completely left behind. But those who do apply deep learning and computer vision, it would give them, to put it bluntly, the right to survive. But the barrier of entry is low, such that their competitors would also, with a reasonable amount of time and resources, would be able to obtain good results. In some other areas, it's much more challenging to do deep learning. So I give the example of cybersecurity as one example. Because the data is so much more complex, it takes at least a year or two just to develop a dedicated deep learning framework for this problem. Now that is the downside of that. It's really complex to apply deep learning in some areas, such as cybersecurity. But the direct advantage of that would be that when a company manages to successfully employ deep learning, it will have a very big sustainable advantage because of that initial complexity. So my advice would be for anyone in any field that they see that the implementation of deep learning is complex, not to give up, but contrary. The fact that the implementation is complex just means that if they do succeed in implementing it efficiently, they may have a substantial and sustained advantage over their competitors.
Okay, brilliant. And so obviously you just mentioned that cybersecurity is one of the industries where it's quite difficult and challenging to implement AI. But on the flip side, do you see any industries that are going to particularly storm ahead with the application of deep learning?
Definitely, we already see, just in the past few days, there were several amazing papers published in the application of deep learning in the medical field. Yesterday, I saw the paper in Nature of DeepMind Group using deep learning for retinal scans to predict cardiovascular disease. Another paper, again, in the Nature magazine, using deep learning for more accurately classifying colorectal cancer. So in the area of medical imagery, we already see huge improvements directly due to deep learning. Just end-to-end deep learning, the input is raw pixels, you train that, and the results are good. In the field of autonomous driving, companies are getting, the results are getting closer and closer to human level. And I think everyone expects that in a matter of years, again, it can be 5 years or 20 years, but I think everyone agrees that in the long run, autonomous driving, fully autonomous driving will replace human driving. In the area of computer vision, we've seen this big improvement. In the area of speech, just a few years ago, speech synthesis, creating artificial conversations, was something that was very, very difficult. Today, if you look at the results, mainly those obtained by Google, they're indistinguishable from the synthesized speech is virtually indistinguishable from human-generated speech. So there are big improvements there. I do expect that the biggest improvements that are to come and haven't arrived yet in the next few years would be in the area of language processing. We still see that traditional methods are required in natural language processing and language understanding, but with more and more efficient deep learning algorithms and improvements in the next few years, and especially much, much faster hardware, I do expect a big improvement there. Another limitation today is the inefficiency of many deep learning models. For example, it's very, very difficult, if not next to impossible, to run deep learning models on environments which are which have constrained resources. For example, in IoT, in devices that have limited amount of memory, limited amount of CPU, or require very fast predictions, low latency. In these areas, we still see that the implementation of deep learning is quite difficult. So this is another challenging area today that we expect improvements to come in the next few years.
Okay, brilliant. And so for looking at maybe smaller companies who are keen to implement deep learning, does this need to be expensive?
Not necessarily. The greatest cost will be, again, the human experts. Just recently, there was an article in New York Times about the fierce fight on AI experts between the giant companies in the valley, mainly. Here in Israel, we see a very, very competitive market on each and fighting on each and every good AI expert. So the main cost would be the human cost, the cost of researchers, engineers, and those who understand or are capable of implementing advanced deep learning models. Apart from that, actually the costs are not so high. One would need GPUs for training. GPUs do cost several $1,000s per device, but that is nothing compared to supercomputers that a decade ago we needed. And again, the data is important. If the companies already gather the data, even small companies that they already gather the data, then that data could be put to very good use. So to answer your question, it doesn't necessarily need to be expensive, given that you have the human resources.
Yeah, absolutely. And so once companies have decided that they can implement AI or deep learning, how can they make sure that they have the right training sets?
I would go again and check the 3 prerequisites that we mentioned to decide what flavor of AI to use and whether to use traditional heuristic-based AI or machine learning or deep learning, to ask themselves what is the kind of accuracy that they need. It's completely different from one business to another. Even face recognition. It depends whether you would like face recognition to unlike your mobile device, or you would like to apply face recognition to scan all the faces of people that arrive every day in the Heathrow airport to compare them to a list of suspects. It's the same algorithm, face recognition, but the kind of accuracy required is completely different. So my suggestion would be not to fall in love with the algorithm and ask what is the result that one may want. It is possible that for a certain use case, even lower accuracies are perfectly fine, and there is no need to go into more advanced deep learning methods, which would be redundant. And in some other applications, even the most advanced deep learning approaches that we have today would not obtain those kind of results. So that would be a main question. The other question would be the amount of data. Even if one has the best deep learning experts, the best hardware and everything, if we don't have the training data, all of that is redundant. And in that case, manually hard-coded heuristics would perform better than any self-learning method in the absence of data. And finally, whether the data, the quantity and quality of data is of complex nature. If it is not, then again, maybe more traditional methods would be just as good.
Yeah, absolutely. And so how do you think that an organizational structure of a company would be impacted once they've implemented AI or deep learning into their business?
There would be naturally more and more AI-related researchers in such an organization. The moment AI starts providing better and more accurate results, the expectations become very quickly much higher than that. Inevitably, all the AI methods that we have and we will have are statistics-based methods. They will never be 100% accurate, even if they are much more accurate than humans. So there is a growing need to understand, to expect an explanation why certain mistake was made, why certain error was made, why they're false positive, why they're false negative. And even though we cannot fully explain, and in most cases we cannot explain the decisions made by black box AI methods like such as deep learning, we would need more and more AI capabilities to provide some sort of explanation or some sort of feedback loop to humans. Just to give an example, in our case, in Deep Instinct, we train deep learning model to detect whether a file is malicious or legitimate. The input is raw bytes, the output is a malicious or legitimate prediction. So our results were much and are still much higher than our competitors. We detect more malware with lower false positive. So when we had our early version of the product, we were of course very proud of that. The results were great. But nearly every customer of ours asked, well, I see that your accuracy is better than anything else I have. But when your solution detects that something is malicious, I would like to know why. And we could not provide that because the prediction was the result of a neural network that even I cannot understand why it says something is malicious. But after receiving such a feedback from virtually all our customers, we went and put additional effort and trained a second deep learning neural model that receives the output of the first deep learning model and assuming that the file is malicious tries to classify it, what kind of malicious file it is. It's very similar to having a first neural network that detects whether there are any dogs in the images and a second neural network that tries to predict what breed of dog is there in the images. So my expectation is that more different companies use AI and obtain better and better results. The feedback from the users and customers would result in them having to put even additional efforts on even better and better AI systems. So it's a kind of self-feeding loop, but in a positive sense, self-feeding, improving loop that will over time result in more and more people working in the AI field within the company.
Yeah, absolutely. And to support these new elements and the operations of the business, do you see a chief AI officer becoming a required position?
Definitely. That is something that in the next few years we will see more and more companies having a chief AI officer. Just take an example. Just a few years ago, companies used to have the chief technology officer, a CTO. Or chief information officer, CIO. But now most companies also have CISO, chief information security officer, because the challenges of cybersecurity are too big to just put them under a CIO, so that there is another C-level position in charge of that. And AI will be even a bigger area of importance to all the companies, and there need to be a dedicated chief AI officer. So I'm sure starting from Fortune 500 companies up to small companies, nearly all of them would need a chief AI officer.
Okay, brilliant. Well, thank you so much. I think we've come to the end of our questions now, but if anyone listening in has a question that you'd like to ask Eli, please go ahead and pop it in the questions box now. And also we have a load of online resources. So we have the white paper that you can download, and we have a newsletter that you can subscribe to, as well as our Women in AI podcast. So please feel free to visit our website and subscribe to anything there. And Eli, before we go, did you have anything else that you wanted to add at all?
I would certainly encourage everyone in the industry interested in the applications of deep learning to do attend the Deep Learning Summit conferences organized by Reward. That frequently get asked by other colleagues, not academic colleagues of mine. Of course, academic colleagues, I tell them to go to the academic conferences that I see them everywhere. But I think the Deep Learning Summit that I personally try to attend both London, San Francisco, and hopefully elsewhere. It is currently the best deep learning related conference, which is relevant for people in the industry, from Fortune 500 companies up to small startups and venture capitals. So for the past 3 years, I've been attending it, and year after year, I see that there's a more variety of people, a higher quality of content, and I certainly plan to attend within the next year. And I do encourage everyone interested in this field and the applications, real world and commercial deployments of deep learning, to attend these events.
Yeah, thank you so much for that. And for everyone listening in, we've actually got our calendar of events attached as an attachment on the webinar today, but I'll also be sending it around with the follow-up email that will include all of the recordings of today. But yeah, thank you so much, Eli. I think we've
Thank you very much. It was a pleasure.
Sorry, just quickly, I've just got a question coming in that will probably be of interest if you could answer for us quickly. What are the biggest cybersecurity threats facing businesses now, and how can AI actually help those?
During the past year, we've seen quite scary things in cybersecurity. Just over a year ago, ransomware attacks in which they encrypt your files and they ask you to pay a few bitcoins to decrypt them, used to attack individuals. What happened during the past year? The same kind of attacks are now attacking large companies. Many hospitals in the UK, the railway system in Germany were brought to complete standstill. Companies like Maersk, the largest shipping company in the world, FedEx, Merck, the pharmaceutical company, sustains huge losses of up to hundreds of millions of dollars of loss due to cyber attacks. And we're seeing a very worrying trend that the attacks are becoming more sophisticated and more targeted. And the traditional methods that we used to have, from signature-based methods to dynamic analysis and heuristics, have no chance of coping with them. It is extremely easy to take a malicious file and mutate it such that nobody would detect it. So the only way to have a chance of dealing with these continuously improving attacks is using much improved methods. And we are using deep learning, and for the same reasons that deep learning is much better at detecting cats and dogs in images and distinguishing voices and classifying documents, for the same reasons we see huge improvements in better detecting malicious files. I do expect deep learning to be applied much more widely in cybersecurity for analyzing network traffic, finding anomalies, for preventing phishing attacks, etc. So for the same reason that deep learning revolutionized other domains, it is, as we speak, revolutionizing cybersecurity.
Okay, brilliant. And how can AI help in mechanical engineering designing? Sorry, this is just another question that's come in. How can AI help in mechanical engineering design of CAD software and optimizing that? Of CAD software.
Mm-hmm. It would depend, again, on the kind of data that we have. In many kind of mechanical design areas, one would need very, very precise results. In those cases, it is a bit more challenging to apply statistical methods such as neural networks because the results are approximation. However, the combination of neural networks with areas such as evolutionary computation, genetic algorithms, usually results in exciting results in the areas of mechanical design. So the person who asked this question, I would encourage them to look up genetic algorithms and the applications of the genetic algorithms to mechanical design. There have been some very exciting progress in the past few years, and that can be combined or without the combination of neural networks.
Okay, great. Thank you so much. And we've just got a question sort of surrounding the ethical implications of AI here. So when users build a relationship with an AI, say, for example, a chatbot or a home assistant, and start to trust it after a few interactions, there's obviously a responsibility for the AI here, and it needs to be held accountable for its actions and decisions. should businesses be accountable for how much of the user shares? Should the businesses be accountable for how the machine and the user shares the data, or should this be the user's responsibility?
That's a good question for which I don't think nobody has a definite answer. But the more the AI is becoming closer and closer to human level of cognition, we will see more and more moral and ethical dilemmas. So on one hand, it doesn't make sense to have the companies developing them to make them accountable. Imagine now that as we're developing bigger and bigger neural networks, these are black boxes. We don't understand the thinking process. But if you look at the other side of the coin, we don't understand the thinking process of our own brains. When we think that we understand why we reach a certain decision or why we entertain a certain thought, the reasons that we think are usually an illusion, and the real reason for why we thought and we said something is completely different, and there is a different neural pathway that resulted into that. So the biggest problem is that we don't understand, and we have nearly no chance of fully understanding neural processes, whether real neural networks, our brain, or artificial neural networks. So imagine a company providing a solution which is based on a very large neural network. It is learning learning to adapt itself to its users by interacting with them. And then what if it would provide a recommendation that would result in a bad outcome, in a bad consequence? It doesn't make sense to make the company that developed it accountable, because there is no possible way for it to predict this kind of results. So I would say that in the next few years, we will see more and more such dilemmas for which the entire world, we should think how to cope with them. But down the road, in several tens of years from now, when I think inevitably artificial intelligence would be as smart, if not much smarter than the real intelligence, then we would more or less view it and expect from it what we expect from other humans. I don't think there is any other way around that.
Yeah, absolutely. Well, thank you so much for answering those questions. That's been great. It's been great to have you here. Yeah, thank you very much for this afternoon. And
thank you very much. It was a pleasure.
Great, thank you. And everyone else will be in touch soon with the recording and some more information.
Thank you very much.
Thank you. Goodbye.